The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now what we're going to do is we're going to convert grams to grams. When 450 megagrams of methane combusts, what mass of carbon dioxide is produced? First, what we want to do is we want to see if our equation is balanced. Is our equation balanced here? No, it's not. You can pause the video now, try it yourself, but for the rest of us, I'm going to continue. In order to balance this equation, we're going to need to place a 2 here and a 2 here as well. Now our equation is balanced. Secondly, before we actually do our conversions, we need to be comfortable with going from megagrams to, we're going to need to go from megagrams to grams. Thus, let's revisit a slide that we covered when we were covering SI unit prefixes, and that was right here. And if we see here, prefix mega, right, gives us a conversion factor of 10 to the power of 6. And what that's telling us then is that 1 megagram is equivalent to 10 to the power of 6 grams. Great. Now that we know that, let's go back and fill that into our, oh, we were right here, yes. Thus, the mass of methane, right? We're being given 450 megagrams. We'll just convert that to grams. It's going to be, our conversion factor is going to be 10 to the 6 grams over 1 megagram. Now, to make this problem even easier, what we can actually do is write our megagrams in their scientific notation as such. 4.50 times 10 to the power of 2 megagrams, right? This is going to be 10 to the power of 6 grams, 1 megagram. Here we are. Wonderful. Now, if we recall from a previous lecture where we covered exponents, we had demonstrated that when we're multiplying exponents, in this case that's going to be 10 to the power of 2 and 10 to the power of 6, what we're actually doing is adding them. Thus, all we're going to need to do is just add this 2 and this 6, and we have our answer. Thus, the mass of our methane here, that's just going to be 4.50 times 10 to the power of 8 grams. There we are. Wonderful. Now that we have our grams, let's go back to our stoichiometric conversion here, and what we'll do is we'll take a look at where we are and where we're trying to go and see how many conversions we're going to need to make. We initially have here we're going to have grams of our methane, right? And then what we're going to need to do is we're going to need to get into moles of methane. That's going to be one conversion. And then from moles of methane, we're going to need to convert to moles of carbon dioxide. And then we can use the mole ratio in taking that step. Next, once we have moles of carbon dioxide, we're going to need to get into grams of carbon dioxide. That's going to be our third step there. Thus, we're going to need to do 3 conversions. Great. Now, if we go to our slide, we can go ahead and set that up. Wonderful. Beginning here with our mass, which we have as 4.5 times 10 to the power, and this is where we left off, right? 4.5 times 10 to the power of 8 grams of our methane. Now, what we need to do, we said we're going to need to make 3 conversions. Thus, without even filling in the numbers, we can just go ahead and make this line a little shorter. We can just go ahead and write in 3 conversion factors, 2, and then we'll do another one down here. That's going to give us our grams of carbon dioxide. Firstly, we said we needed to go from grams to moles of methane, right? And then we know that per mole of methane, what is going to be the molar mass? Well, 12 plus 4, that's going to be 16 grams, right? 16 grams here for our methane. Now we need to do our mole ratio. next to get into moles of carbon dioxide. And how can we do that? Well, we can do that from our balanced chemical equation. Here, how many moles of methane here are reacting? We have a mole, yeah? And then how many moles of carbon dioxide are being produced? It's a 1-to-1 mole ratio, right? Thus, we would just do a 1-to-1 mole ratio here. And that is for our mole of carbon dioxide. Great. Now that we're in moles of carbon dioxide, what we actually need to do next is we now get into our grams. And in doing so, we know that per mole of carbon dioxide, we have 44 grams, right, of carbon dioxide. And once we go ahead and we equate this, we get a value of 1.2 times 10 to the power of 9 grams of carbon dioxide. And there we are. It's as simple as that. Thus, for when 450 megagrams of methane combusts, 1.2 times 10 to the power of 9 grams of carbon dioxide is produced. Wonderful. Let's now move on to our next slide. What are we being asked? What are we being asked here now? Now what we're going to do is we're going to go from grams to molarity.